then that represents Bitcoin. If you write 501 over here, that represents Solana. So this second last character over here represents whose public private key are you creating? Are you creating Solana's public private key for the 0th wallet? Are you creating Solana's public private key for the first wallet? Or are you creating Ethereum's public private key for the first wallet? As long as the derivation path is the same, अगर तुम second wallet ही बना रहे हो, if you are making the second wallet in Backpack, or maybe let's say the third wallet over here, then this derivation path will always give you the same public private key as long as you have the seed phrase. That's the concept of HD wallets. If you've ever gone through, let me maybe do this with me. If you've not already done this, uninstall Backpack if you had. How do you uninstall? Manage extensions, remove Backpack, and install Backpack with me once. Go to backpack.app, click on download extension, add this to Chrome. Of many wallets available. Wallets are, very big businesses. All of these companies are. Phantom is worth $1 billion. MetaMask is worth a multi-billion dollars. Backpack raised at $100 million. So all these are big businesses. How do they work? They're actually fairly simple if you read at the code. As soon as you add the extension, they take you through what's called the onboarding flow. And in this onboarding flow, when you click on create a new wallet, you select a blockchain, let's say Solana. It gives you your mnemonic. I repeat, if you go to the next slide, you will see the very first jargon I had over here was a mnemonic. A mnemonic is basically a human readable string, as you can see over here. Fairly human readable, right? Random, allow, excite, begin, easily, syrup, so on and so forth. Fairly human readable. This is the only thing I need to write down and put in my locker. I repeat, as long as I have this mnemonic, every wallet that I create in Backpack after this, I can derive from this mnemonic. So this mnemonic is, very similar to, not exactly, but very similar to this single seed that I've written. It is not this single seed. From this mnemonic, you can generate the single seed deterministically. Deterministically का मतलब होता है कि यार हर बार, every time, if you use these 12 characters, the same seed phrase will come out. That is what determinism means. Okay, if I do it on my computer or if I do it on your computer, doesn't matter. As long as the 12 letters are the same, or words are the same, the single seed phrase will also remain the same. So that is what I've done here. Clicked on next, put a password. This password has nothing to do with the blockchain. It is a local password for, Backpack. I have to go through it again. This password is a local password for Backpack, has not, so that if your laptop is with your friend and they quickly click on Backpack over here, they can't, immediately see your funds. That is why that password is there. That password is not, password protecting this seed phrase or anything. Now, if I add more wallets, I add another Solana wallet, then this Solana wallet is probably being generated from a different derivation path. Maybe this one right here. Then let's say I add a third wallet. This third wallet is probably being generated from this derivation path, so on and so forth. So the jargon to learn here was number one, mnemonics. What is a mnemonic? This thing right here. I also have a photo from this video where, some cops found some criminals car, and inside the car, they found their seed phrase. As you can see, this is a seed phrase from which, the cops can pull out the user's funds and everything, because this seed phrase is something from which you can derive this. From this, you can derive the public and private key of every wallet. So you should keep this very safe. If the cops get it, if your friend gets it, they can steal all of your funds. The seed phrase is thing that you can derive from the 12 words that we had written. So what is the second jargon over here? Seed phrase. How do you generate it? There is this BIP 39 library, Bitcoin Improvement Proposal 39, not 32, 39, which has these functions called, generate mnemonic or mnemonic to seed. The generate mnemonic function will generate this very long string. We will also use this when we create our own web-based wallet today. And mnemonic to seed sync will convert your characters or your words over to a seed phrase. Given you have this seed, you can generate as many wallets as you want. If you want to generate each one of these, अभी तक समझ आया? पहले ये बताओ, before I proceed, do we understand this much? Can we do a poll? बोलो समझ आया? 86%, 85%. Let me finish this. Let me finish the class. I will try to wrap up by 9:15. Ask as many questions after that. Okay. Let me try to finish the class by 8, by 9:15, 9:30ish. Okay. Bear with me until then. 15%, 85%, good to go. All right. Let's understand the significance of these, various subpaths in a derivation path. M means the root seed over here. 44 means, which this specific thing is, I'm also not very clear on. A constant that defines the purpose of this wallet. 44 for BIP 44. Usually, I've seen only 44 in most wallets as the second, word over here. It represents the purpose, which I don't understand what the purpose. It probably means, in the future, if there is a better proposal for a better derivation path, you'll put that number over here. I don't know, probably. The third one represents which blockchain are you using. Even though, derivation paths were introduced in the Bitcoin approval proposal, they were so futuristic. जिसने भी बनाया था वो, उसने इतनी आगे सोचा था कि यार, he said the third character will be what blockchain is using it. In 2012 itself, that person predicted that there will be many blockchains in the future. So let the third string over here be which blockchain do you want to create the public private key for. 60 is for Ethereum, 0 is for Bitcoin, 501 is for Solana. So if you want to generate a Solana public private key, you put 501 here. If you want to generate Ethereum public private key, you put 60 here. Bitcoin, you put 0 here. And lastly, this last character is which wallet you want to create. Wallet number 1, wallet number 2, wallet number 3. Okay? That is how you generate these multiple public and private keys. This is the code for it. And more specifically, if you look at the Backpack code base, you'll find, okay, Backpack has various derivation path options, but this is the one that they actually end up using. This, if you look at the code, you'll see, they use derivation path options of 0, which means, this specific derivation path is used for Solana. It is M/44/501. 501 was for Solana /X. X basically means, 0, 1, 2, 3, 4. What wallet are you creating? /0. This is the derivation path that Backpack uses. If you go through the offline video that I released today, you will find, I write some code that generates the same wallet addresses, ABWC, 5XPJ, 9FLF, whatever this is. These same wallet addresses I was able to create in my web-based wallet as long as the mnemonic was the same. Of course, I can have the same public private keys. If I have the same seed phrase, I will have the same seed phrase as this wallet in Backpack as long as I have the same mnemonic. So the mnemonic that I used while onboarding, the 12 words that I saw, which, I think you can export here as well. Account, show recovery phrase. These 12 characters, as long as I use them even in my web-based wallet, I will be able to generate the same public and private keys as Backpack has over here. That is what HD wallets are. And, why were we discussing HD wallets? Let me quickly recap what I've done until now. In today's class, we were supposed to understand a new hashing algorithm that Ethereum uses. KEKK 256, something like this. We were supposed to understand this hashing algorithm. We will also. Before we get there, I shared a little bit about what are HD wallets. What are HD wallets? Hierarchically deterministic wallets. They basically say कि तुम्हें कभी wallet बनाना है ना जिंदगी में, if you ever want to create a wallet, first create a 12-word seed phrase. First, create a 12-word mnemonic. What is this called? This is called a mnemonic. From this mnemonic, you will be able to create a seed phrase. From this seed phrase, you can derive various public private keys on various blockchains based on some derivation paths. Derivation paths. These are the four jargons that you had to learn. Jargon number one, mnemonic. Jargon number two, seed phrase. Jargon number three, derivation path, and then public private key pairs over here. Hopefully we understand this. If not, as I said, last offline video covers this. Now the goal is understanding the hashing algorithm, or more specifically, why is it used? Why is it used? Because in case of Ethereum, whenever you generate this public private key, the public key that you give out to your friends is not what the algorithm gave you. It is a slightly twisted version of it. You first hash it using this algorithm, and then you take the last 20 bytes of it. That is what your public key is. These are, the steps that are followed to generate a public key. Number one, initially a public key is generated using an elliptic curve cryptography. Harkirat, what is elliptic curve cryptography? If you go back to the slides from last week, यहाँ पे we covered asymmetric encryption can be done using one of many algorithms. The algorithm that Ethereum and Bitcoin use is ECDSA, which uses elliptic curve cryptography. The algorithm that Solana uses is EDDSA. Both of these use elliptic curve cryptography. Harkirat, what is elliptic curve cryptography? It is a way for you to generate public and private keys such that they, follow the asymmetric encryption algorithm. The public key and private key are slightly related such that you can, sign using a private key and verify using a public key. Yet, given the public key, you can't find the private key. If I share my Solana public key with all of you, you will not be able to tell कि हरकिरत ये है तुम्हारी private key. You can't derive the private key from this public key. That is what all of these algorithms sort of follow. For Solana, the public key is simple. क्या जो भी 32 bytes होते हैं ना, you convert it into base 58. That is it. Doesn't do anything special. For Ethereum, if you really look under the hood, I also sort of from Backpack's code base reach the Ether code base, and after a few points reach this compute address function. If you look at this function, it calls this hashing algorithm on the public key dot substring 4. Why do they do substring 4? Because if you again go to the signing key class, you will find that the public key is padded with something extra. So it removes the first 4 characters, which this signing key dot public key is padded with. Feel free to go through this class. You'll find a comment that says, the first 4 characters are something extra. So we remove it and we do a dot substring 26. Why do we do dot substring 26? Do a little bit of math. Okay, when you convert this is 32 bytes. What do we have to convert it down into? We need to convert it down into 20 bytes. So, we have to remove 12 bytes from it. So ideally this should be dot 2 substring 24 because, this will be in hexadecimal. I'm again confusing a little too much. You don't have to understand this code. But, if you look at this code, high level, what is it doing? It is first converting your public key using this algorithm. Then it is finding a smaller substring of it. Now, why is it 26 over here? Forget for now. But does this line of code, let me copy this line of code and paste it, right next to this thing right here. How can I paste it? Let me take a screenshot of this. If you don't understand this code base, it's fine. I'm just showing you the source of, this is actually happening in Ethers. This code base that I just showed you is in this Ethers library. Why am I showing you the Ethers library? Because if you look at the Backpack code base, they are using the Ethers library to generate this wallet. So I wanted to show you the source of the public key because Backpack has used a very high level API. This is how we derive the public key. New wallet private key khatam. Nowhere have they mentioned how is the public key generated. So I went to the wallet class in Ethers from which I, this function right here called compute address. And here I am showing you, okay, the final public address is actually first converting the public key over or hashing the public key to this 32 byte string and then finding a substring of it, just the last bytes over here. That is the final thing that you share with your friends. If you look at my, Ethereum wallet over here, let me create a fresh Ethereum wallet, you will see, its public key is actually slightly smaller than the Solana public key. And the reason for that is it's just 20 bytes in nature. How does it become 20 bytes in nature? By first hashing it and then taking the last 20 bytes of it. Do we understand thoda the significance of this algorithm in Ethereum? It has other significances as well. As we write smart contracts, you will see this algorithm is used, there as well. But for now, do we understand the difference between Ethereum and Solana in generating public keys? And where is this algorithm used? All right. We understand it 93%. Amazing. ठीक है जी. This was the only, new thing for non-full stack developers. Sorry, for full stack developers. इसके बाद, it will go like this for people who know full stack. For people who don't know full stack, it will be a little complicated. So let me go to the next slide. The next slide is about front ends versus back ends and HTTP servers. Most of you have heard of full stack development. Hopefully you understand, there is something called the front end that you usually write in React, HTML, CSS, JavaScript, which talks to a backend, which is basically a server that's somewhere out in the world. For example, if I go to google.com over here, you will see if I right click on inspect, go to the network tab, refresh, you will see a bunch of something is present here, right? And it is present in the network tab. These are what are called HTTP requests. You are sending a bunch of requests to a server somewhere. What are you doing over here? Whenever you go to any website, be it google.com, you send a bunch of requests to some server in the US. It responds back with, some HTML, some CSS, sometimes some JSON data, so on and so forth. You fetch that data from somewhere on the internet. The same thing happens when I go to, a block explorer. Harkirat, what is a block explorer? Something like soulscan.io. If I go to this website and, try to search for one of my addresses, okay, how much money do I have in this address? Not a Ethereum address, but a Solana address. If I try to find how much money do I have in this Solana address, it tells me you have zero money right now. Here also, it is sending a request somewhere. The goal is for us to understand where is it sending the request? How can you send a request over to the blockchain so that you can find things like these? How much Solana does this address have? Why do you want to do that? Why would you want to send a request to the Solana blockchain? So that you can show the user. Eventually, our goal is to make a web-based wallet. We want to show the user, yeah, you have 2 SOL right now, you have 1 SOL right now, you have this much amount of SOL. So for that, we need to talk to a backend server. Backend servers in full stack are servers which run your backend logic. It's a very vague statement. Basically, it is a machine somewhere out there in the world. If you've heard of AWS, Google Cloud, Azure, somewhere in the US, you rent a machine, you start running some code over there. A few such machines are running, blockchain code. And you can talk to these machines and ask, hey, what is the balance of this specific public address? You can talk to these machines and they will tell you, okay, acha, for this, public address, there is 0 Solana in this person's wallet. This is what, we have to sort of use to be able to create a web-based wallet. We need to understand what are these backend servers? How can I get one of these backend servers? How can I send a request to it so that the backend server responds back with, you have 0 SOL for this address. A good example of a backend request is this. Harkirat, this looks like a website. It does, but look at the data. It returns you what's called JSON data. It just dumps a lot of data for you, which is why this is a traditional backend request. This isn't a front-end request. It is returning you, a random post in this case, which has some title and some body. So that is why this is considered to be a backend request compared to, let's say the request that gives you this UI over here. That is also a backend request. Only, that backend request returns you HTML. If I refresh this page, if I go to the top, You will see the very first request that I send out. Uh, the very first request that I send out returns you, let's filter, let's go to google.com. I know some of you are getting really bored right now, the advanced folks. Give me 5 minutes. We're going to wrap this up very quickly. The very first request that goes out that, is there you go. This one right here is also sort of a backend request. Only it returns you some HTML. It returns you some HTML. So it is, you can say it's a front end request, but ideally everything that you see over here is a backend request. And irrespective of if it is returning you HTML or if it is returning you JSON data like this. How many of you know about Postman? Can we do a quick poll? Akash, have we played with Postman in the past? Do you know what Postman is? Most of people know. 80% know. So let me give a very brief, 1 minute intro. You can send these requests from a browser. I repeat, when I go to Google, you saw so many requests go out. You can also send these requests from Postman. Postman, as the name suggests, Postman, which means it lets you send what are called post requests. Harkirat, what are post requests? We will get to them in the web dev cohort. Don't worry about it right now. If you already have Postman, great. If you don't have it yet, install it after the class and try to digest a bunch of this. Or at the end of the class, I'll help you install it. Whatever, either way is fine. This also lets you send backend requests. Notice the request I have over here. I have some Ethereum address written over here, eth-mainnet.g.alchemy.com. Very similar to how I was sending a request to google.com. This time I'm sending it to some random URL for some alchemy.com website. And along with the request, I am sending some data with it. This data, if you look at it, it's what's called JSON. It's like a JavaScript object, right? It has a key and a value. What is the first key? Okay, bhai, what version of JSON RPC are you using? Harkirat, another jargon, JSON RPC. 2 minutes, bear with me. In the next slide, we'll cover this. But this is telling the server, ki, hey, this is the version of JSON RPC I'm using. Random ID send doesn't matter. This is the method I want to invoke. What does it say? JSON RPC. What does RPC stand for? Remote procedure call. This is the procedure I want to call. This is the function I want to call. This is the arguments that I want to call that function with. Assume okay, in the backend, there is this eth underscore get balance function that, this server has, and it accepts two arguments, an address and let's say the time. You are trying to call this eth underscore get balance function on that backend with these two arguments. Harkirat, how is this function being called if I click on the send button over here? And the answer is JSON RPC. That server on the backend, I repeat, that server on the backend is running the JSON RPC protocol. If this is that Alchemy server, what was the name of that website? The name of the website was Alchemy. This request that I'm sending looks something like this. It has the version of JSON RPC to the method. What function do I want to call there? It was eth underscore get balance and the arguments, which is what are the arguments that I want to call on the function that exists over here. There is a function over here called eth underscore get balance. And I'm sort of from my browser, I'm sending a request that is telling the server, hey, please call this function with these arguments. And whatever response comes back, send it back to me. That is what the JSON RPC protocol dictates. RPC is a more generic term, remote procedure call. There are various versions of RPC. There is TRPC, there is gRPC, and the one that we're discussing right now is JSON RPC. Why is it called JSON RPC? Because your input is JSON, you are sending the name of the method and the arguments of the method in JSON format, and the server is sort of calling this method using these arguments and returning you the response. So what does it stand for? RPC stands for remote procedure call. What is procedure? Procedure and function are the same thing. Procedure and function are the same thing. So remote procedure call means what? I am remotely calling a function. एक फंक्शन है जो एक सर्वर में एग्जिस्ट करता है इन द यूएस. देयर इज अ फंक्शन दैट एग्जिस्ट इन अ सर्वर इन द यूएस, and I am calling this function remotely. Hence, it is called a remote procedure call. Since the way I am sending the data is in JSON, I repeat, the way I am sending the data, my inputs over here are in JSON format. Hence, it is called JSON RPC. You can always create your own JSON RPC servers as well. But in this case, Solana, Ethereum, both of them, also support JSON RPC servers. In the future, when we create, HTTP servers of our own, we can also create our own RPC servers. It's not like this is blockchain restricted. Anyone can create RPC servers. Anyone can create JSON RPC servers. Ethereum and Solana also, sort of have JSON RPC servers that you can talk to. What is happening again? You as the user are sending a request to an RPC server. RPC server responds back with whatever that function call returned, which in this case is get me the balance of this specific address. It will respond back with, let's say 0.1 sol, which is, let's say the amount that this specific address over here has. Let's try that out. I called ETH underscore get balance. It returned me this, hexadecimal string. This is actually one of my very old wallets on Ethereum, I think. It returned me this data. If I convert this hex to number, it tells me I have not this much Ethereum. I have, this divided by 10 raised to the power 18 Ethereum. We'll come to this very soon as well. But I don't have this much Ethereum. I have 0.000014 Ethereum, something like that. If I copy this address again and go to, let's say, Etherscan and paste it over here, you will see I have 0.00014 Ethereum. I don't have this much Ethereum. It's just a different unit in which it returns you the response. We'll be coming to what that unit is very soon. Do we understand how you can use RPC servers that Ethereum has to send requests and get back some response? %87. Good, not great. Let's proceed a bit. Happy to answer questions. We'll be playing with these very soon. So, if you don't understand it right now, it is fine. JSON RPC is a remote procedure call protocol encoded in JSON. It allows for communication between a client, in this case, my postman is the client, and a server, an RPC server that, Ethereum has or Solana has. As a user, you interact with the blockchain for two purposes. You either send a transaction, you want to send someone money, you want to change something on your account, or you want to fetch some data on the blockchain. You will either just get data, or you will tell the blockchain, I want to send someone some money. If I open a wallet over here, as soon as I open it, there is some request going to some RPC server, which is responding back with Harkirat has $0 or this wallet has $0. If I change it, again, a request is going to an RPC server. Server is telling back here, you to have $0 right now. If I click on send and, select a token, if I had a token, started to send this token to someone, then also I'm talking to an RPC server only. But in this case, I'm sending it something extra. Here is a signature. I want to send someone $2. So these are the two cases in which you interact with the RPC server. Either you want to fetch some data or you want to submit a transaction on the blockchain. What we are going to do today is just fetching data, fetching the response for a wallet. But the assignment that I gave at the beginning of the class was, try to support the send functionality. Try to support the send functionality, which means, you will have to explore a little bit and understand how can you do the point number 1 over here. Point number 2, I will cover today. Point number 1, I will cover next week, but I would urge you to try yourself. In both of these, the way to interact with the blockchain using JSON RPC, that's pretty much it. Let's skip this slide for now. Let me take you through how you can get an RPC server. This is sort of important. As I said, an RPC server is, not exactly a miner. Miner nodes are different. They are actually doing consensus, doing proof of work, everything. RPC node, sits on the side. It still talks to the blockchain from time to time. If I ask it for get balance, it will have to ask one of the nodes on the blockchain only for my balance. But it does a lot of caching, does a lot of rate limiting. You can scale this independent of the miner. Scaling a miner is a whole different task. If you're on Bitcoin, if you're scaling a miner, you have to make sure it's a big machine. If you're on Ethereum, then if you're scaling the miner, you have to give it some stake. Here's what is stake, don't worry about. But it's very hard to bring up more nodes. Sort of easy to bring up more RPC nodes. These are very lightweight nodes. And they just, you talk to them, they talk to the blockchain and return you whatever data you want. How can you get an RPC node? Here, I would, you can bring up your own as well. Don't do it. Rarely do you do it. Even the biggest companies don't do it. Everyone delegates it. These are, the four companies. There are much more. This is a very popular business in crypto. Is providing RPC servers as a service to other users. Every wallet, as I said, if I open Backpack over here, under the hood, it is sending a request to one such RPC server only. Whenever I change my wallet, it asks that RPC server, how much balance does Harkirat have? Backpack doesn't own its RPC servers. Even Phantom doesn't. Everyone delegates it to one of these companies. So we will also use one of these companies today to get you your own RPC server. So pick any one of these. I'm just going to use Alchemy because it has a decent UI and has a free tier as well. So go to Alchemy, sign up, sign in really quickly for me. Let's take 30 seconds to sign in. And then we'll go from there. Fifteen more seconds, then we'll proceed. All right. Hopefully that's easy signing up. After you've signed up, you'll see a button called create a new app. Just click here, give it a name. Let's say, I have reached the app limit, so I cannot, but you guys should do it. Go through the process, give it a random name, select a use case. Once you do, you'll see an app like this on your dashboard. Take 20 seconds, do it. Create a new app, try to explore it a little bit. I already have these three apps, which is why I can't create a fourth one without upgrading, but you should be able to do it for free. 10 more seconds, then I will proceed. All right. Here you will see after you open one of your apps that you just created, there'll be a section called networks. These are your RPC server URLs. This is where I got my Ethereum RPC URL from. This is where you can get your Solana RPC URL from. This is what you will use to, talk to the blockchain. And as I said, even the biggest companies use someone else. These folks do the heavy lifting of, putting this node, making sure the node talks to a full node over here. They also have, their full nodes deployed. So, it's a hard task. You delegate it to someone else. Cool. Can you now open Postman and on your own RPC server, try to send a few requests on your own Ethereum RPC server? Try to send a request to, let's say, get the balance of a specific, wallet address. Let me paste at least mine in chat. So worst case, you can try mine only. Or, replace it with your own Ethereum address or someone else's Ethereum address. And it'll return you how much Ethereum that specific person has. Take 20 seconds, get comfortable with it. Maybe try the Solana RPC as well. There is the Solana RPC over here. If I replace the URL with Solana RPC and the contents with what Solana RPC server, of course, the Solana RPC server won't have a ETH.getBalance method. It will probably have, a sol.getBalance function or something else. Let's see what that something else is. If you go to the slides, I have a slide called common RPC calls on Solana. So if you open this, you will find, the second one is to get the balance of a specific address. So if I paste this over here, click on send, it returns me that this user has, again, I don't have 9 lakh Solana. I have 0.009 Solana, something like that. This number is a little, multiplied by something else. You have to divide it by 10 is per 9. That is how much Solana I actually have. So basically, if you've been able to, create a slightly smarter wallet, something closer to Phantom and Backpack over here, where the user can come. We understand a little bit how can we make the user create more wallets. We also saw, okay, now we can query the blockchain and ask okay, how much Solana does the user have using these RPC methods. So we're getting very close to be able to create our own web-based wallet. The only thing we don't have right now, well, we don't have a bunch of things like activity, NFTs, things like these. But the big next thing to do is add this send functionality, allow users to send their funds to someone else. But we'll get there when we get there. Okay. Quick recap of everything we have done today. Some context, followed by this hashing algorithm that Ethereum uses. Understood that backend systems are different from front-end systems. And a popular backend system in blockchains are RPC servers. What are RPC servers? They are servers that sit right next to the blockchain. Where is that? Very nice. They are servers that sit right next to the blockchain. What do I mean when I say right next to the blockchain? I mean, they're not the primary heavy nodes that do consensus. There's some extra node that sits on the side. And you ask this extra node, okay, hey, can you give me the balance of this specific address? Can you give me how many transactions have happened on the blockchain? So on and so forth. And we learned how can you create your own RPC server. You don't really create a fresh RPC server. You just have, the way these companies work, you just get some small pool. There's a shared RPC node. It's not like you clicked on a button and a new server was created for you. You get the idea. It's just a shared RPC server that a bunch of people are using. Given all of this knowledge, there are some common RPC calls on Solana that I've written here. First one is get account info. It returns you the balance of a user and some extra things. For example, it has this data field over here. We'll get to what this data field is. But here also, if you look at it, it returns me, yeah, I have this many LAMP ports. What are LAMP ports? We'll get to very soon. But it returns me, I have this much SOL in my account. It also returns me some extra things. Okay, who is the owner? How much space have I used? How much data have I put? Which we will get to eventually. But at least I can now query the blockchain for my balance. I can query the blockchain for how many transactions have currently happened on Solana. Currently, the result is, let's say, this big. If I send it again, the number goes even further because Solana has, a lot of transactions happening per second. So I can query the blockchain. Similarly, I can query the Ethereum blockchain as well. Here are some common methods. For example, get the balance of the user, get the latest block number. What is the block number? We go to Alchemy here. Basically, blockchain, one after the other, you're adding a bunch of blocks, right? So the current latest block is, for example, this right here. If I go to again hexadecimal, the current latest block on Ethereum is this, whatever this is, 20 million or 2,054,000, so on and so forth. If I go to Etherscan, you can see the latest block is this 20,054,000 something. I can query the blockchain. I can start to create, a page like this. I can create a website like this. I can start to create read-only websites. Now you have not enough knowledge, but some knowledge to be able to create block explorers like these. What does this block explorer do? It's very similar to a wallet, right? Wallet shows you your existing transactions. Same you can see over here. Wallet lets you, see your balances. Same you can see over here. If I paste, one of my addresses, this address, let's say over here, you saw it showed me my balance, right? So this is not my address, but you get the idea. OX. This was that address, the 0. This is a different address, but you get the idea. I can see the balance of this specific public key. So a block explorer and a wallet have almost similar challenges. Both of them need to query the blockchain for some things. Both of this has a list of the transactions. Here also there is an activity section which will have my list of transactions. This has the how much Ethereum Solana I have. This also has how much Ethereum I have, so on and so forth. The only thing that's left now before we move to creating a wallet, I don't know if we'll do that today, is this smaller units that I've been talking about. Whenever I've been hitting the blockchain, it doesn't return me. One last thing, then I'm open to doubts after that. Whenever I hit the blockchain, it doesn't say, let's see, let's find a good one over here. It doesn't say I have 0.009 Sol. It says I have 9931100 lamp ports. Whenever you are on a blockchain or you are on a financial app, something like Razorpay or Paytm, you don't store user balances in decimals. I repeat, in both of these cases, be it a financial app or the blockchain, the way a user's balance is stored is in integers. It is not stored, uh, in decimals. Why is that? Because decimals have something called precision issues. What are precision issues, Arkirat? Basically, if you ever store 0.1, let x equal to 0.1, it can very easily get converted to 0.999999999, something like this. You can lose some value over here, because programming languages, they aren't optimal when it comes to decimal numbers. In a programming language, if you ever write 0.11, it might get converted into 0.1, 0.99999, something like this. To avoid that, you always store the lowest digit in the database. For example, if you ever look at the Razorpay dashboard or Razorpay webhook data, what is webhook data, don't worry about. But basically, if someone pays rupees 5999, let's say for a course, they send you 599900 like this. They don't send you 5999. They add 2 zeros at the end of it, because Razorpay lets you accept payments until paise, until something like this. You can, I hope you know what Razorpay is. It's a payment gateway that people use to accept payments. If not, let me know later on. But the point is, if you look at Razorpay database ever, it will have the payment information stored like this and not like this. Similarly, on the blockchain, when someone says I'm sending you 0.1 Ethereum, they actually say I'm sending you this much Wei. Wei is another unit of computation. Just like you can say, hey, I sent you 0.1 ETH. You can say I sent you 10 raised to the power 17 Wei. Just how you can say, hey, I sent you $100.1. You can say I sent you, these many pennies. Rather than saying I sent you rupees 100.1, you can say I sent you, 100.10 paise. So the thing on the right is better to store in a database, to store on the blockchain. The thing on the left is better to say. Of course, I would like to say I sent you 0.1 ETH and not 10 is per 17 Wei. But on the blockchain, the way it is stored is this, which is why, it returns me this very big number rather than returning me 0.009, because this is how it's stored on the blockchain. The unit in which it is stored is not Sol, is not ETH. It is this, Wei unit, or in case of Solana, it is this Lamport unit. Wei is the smallest unit of cryptocurrency in Ethereum. It is similar to how a cent is to a dollar. 1 Ether is actually 10 raised to the power 18 Wei. This is how, your balances are stored on the blockchain. There is another unit in Ethereum called Gwei, which is 10 raised per 9. 1 Ether is equal to 10 raised per 9 Gwei. It's slightly bigger than, Wei. If you don't understand this second one, it's fine. I hope it's simple though. It's just another unit, right? Just how you can have thousands of rupees or paise. You can have Wei, you can have Gwei, you can have ETH. 1 ETH is equal to 10 per 18 Wei. 1 ETH is equal to 10 per 9 Gwei. And Lamports are the equivalent in Ethereum, in Solana. 1 Sol is actually equal to 10 per 9 Lamports. Here is some code that you can write on Replit. Const Lamport per Sol equal to require at solana/web3.js. If you log this It will log 10 raised per 9 on the screen, which will, basically tell you, okay, the smallest unit of sending someone Solana is 10 raised per 9, which is why, if it says I have this much lamp ports, it means I actually have, 1, 2, 3, 4, 5, 6, 7, 8, 9, this much Solana. I actually have very little soul in my bank, soul in my wallet. I, of course, have a lot of lamp ports, but, lamp ports mean nothing. They're just a smaller unit. Do we understand this? If you understand this, then, the only thing that's left is this, which, most probably I'm going to cover in an offline video. I'll give a high level overview, but I'll just take doubts after this. Okay, we understand this. Great. It's 9:17. We might actually be able to do the web-based wallet. We'll do a poll and decide. But basically, the goal of this last slide was the assignment from last week. Last week, I just threw a vague assignment. Just like this week, I threw a vague assignment at you to, implement this send feature. I don't expect you to do it yourself. At least last week. This week, you can probably try. But this was what I was, thinking of covering today. A few people have built this. For example, this is a very clean UI that Keshav created, which lets you, generate a mnemonic very similar to how, Backpack's onboarding flow would let you do it. And then, it lets you generate various wallets. If I click on add wallet, it'll keep on adding more and more wallets for me. This looks wrong. I think this add wallet just changes the mnemonic, which is something we don't want. In case of Backpack, you have a single mnemonic from which more and more wallets can be, created. It looks like in this case, he's generating more mnemonics every time. Either way, it's fine. Clean UI looks great. And, a bunch of other people did it as well. If you want to look at Keshav's code, it's right here. I've put it in the slides. Now we can do doubts, or I can take you through how you can do the same thing yourself and have a slightly uglier looking similar application where, user can come, create a seed phrase. Once they've created a seed phrase, they can add more Sol wallets. They can add more ETH wallets, similar to how in Backpack, I can create a mnemonic phrase. Then I can add more Sol wallets. And I can add more, Ethereum wallets. So let's do a poll. Akash, can you create a poll? Should we do doubt session? If we do a doubt session, I will cover this offline. Or should we do this now? And, okay, there is a prerequisite to this though. React. If you don't know React, this will be very hard. Well, kya pucha hai bhai? This should be a different poll, right? How is that? Do you understand the question? Create a fresh poll which asks, which one of these do you want to do? Do you want to create a web-based wallet? Do you want to do a doubt session? Can you do that, Akash? Thank you. Meanwhile, let me look at Q&A. Only I can do that. Makes sense. You cannot do that. So let me do that. What should we do? Create a website. React is a prerequisite. So if you don't know React, you will not be able to understand it. Probably select the second option in that case. Doubt session. Alrighty. I don't want it to be chaotic. If it is ever chaotic, then, I have to do it again in an offline video, which is why, why did you launch the wrong poll again? Don't touch anything, Akash. Let me do it, okay? Launch. There you go. Sorry about that. Can you guys select now which option is more relevant? All right. Bang 50-50. Not bang 50-50. It's 55% doubt session. 45%. We'll have to follow it either way. It's 46% create a website. Let me give a brief overview of the website. As I said, I will cover it in an offline video. Very briefly, to be able to create something like this, which is like an ugly looking version of a wallet like this, you number one have to generate a seed phrase. Before that, you have to initialize an empty React project. That is what we do here. We are using Vite to initialize an empty React project. We do an npm install in there to install all the dependencies. This is one extra step that you need to follow. The thing is, most libraries that we'll be using from now, BIP39, even ED25519 HD key, require a few things that only Node.js has. HTML, CSS, JavaScript don't have that. Or React specifically in this case doesn't have some of these things. For example, buffer, someone asked a few classes ago. Someone asked, Harkirat, what is the difference between a buffer and a uint8 array? And I told, uint8 array is something that you will see in the JavaScript that runs in the browser. But buffer is something you will not find in the browser. You will only find in the Node.js environment. To be able to bring these constructs in your HTML, CSS, JavaScript, environment, you have to add this Vite plugin node polyfills. What does this do? As the name suggests, it's a polyfill for node. It brings some of those dependencies that these libraries use, BIP39 uses, and only then, will you be able to use that library if you add this polyfill. You can also do other things. You can replace the BIP39 library with this other library called BIP39 web or web BIP39, this one right here. In this case, you won't have to do all of this, but then you'll have to find the web versions for all the libraries. This is something I was just doing before the class. This did not work. Then I introduced the web. I found this other library. I started to use this one. But then I saw the same issue in this ED25519. I could have found a web only version of this, but then I just thought, let's just, add the polyfills and make all those libraries, all the code from last week directly work here. So this is one extra step that might for now go above your head, and that's fine if it does. If you use Next.js, you probably don't have to do this. Next.js already comes with these polyfills, I think. So when it was not working for me, I went through Keshav's code. I saw he hasn't done anything extra. It's working for him. Then I realized his project is in Next.js. And then I realized, I can probably just use polyfills here. After you've done this, I clean up app.jsx, whatever random basic code Vite gives us. I add a state variable called mnemonic. Again, if you don't know React, then this is it's fine. You will understand what state variables are eventually in the web dev cohort. I install the BIP39 library. I create a button. When you click on it, it calls the generate mnemonic function from BIP39. It sets the state variable that we defined over here. And then we create an input box inside which we render the mnemonic. This is what leads to, this input box, which is rendering the mnemonic. Anytime you click on this button, this mnemonic gets rendered. By the way, this code is already posted also. So you can go to 100x devs cohort 3. You'll find the code in this repository. You can just look at it here as well. Then I create two components, one called Solana wallet, one called ETH wallet. The Solana wallet component, pretty much renders this button, and all of these, as you click on this button, more and more wallets. Click on ETH wallet component. As you click on it, more and more ETH wallets are created. How is that done? If you know React, should be fairly easy for you to understand. Okay, I have a state variable called current index. Which index are you on? 1, 2, 3, 4. Fourth index I'm on here. And another state variable called addresses, which is what all addresses have already been created, address 1, address 2, address 3, address 4. This is an array. This is a number. And as you click on the button, as you click on the add Sol wallet button or add ETH wallet button, I run this code, which is the same as last week. It, has the derivation path, gets the child node, gets the private key of the child node, creates the wallet, pushes it to the addresses array, which is what gets rendered over here. Happy to take you through it. Not happy to. I will make an offline video on it. Until then, try to do this yourself. And if you can, add a feature over here that shows you the wallet balance of the user. We've already done this, right? It's a simple HTTP call that you have to make. So try to make that call for all of these. And then if you really want to go, one step ahead before next week, try to implement the send feature as well. See how can you send, signatures in this JSON RPC, server. How can you sign a transaction and forward it to an RPC server? Cool. With that, I'm going to open for doubts. If everything was clear, it's all good. You can call it. Let's do a last poll. How was the class? Was it good? Yes or no? Give me a yes or no if the class was good, and then we'll do Q&A afterwards. Hopefully it wasn't too heavy because I think it's a fairly easy class. But let me know if that was not the case. Was the class okay? Good. All right. Good. 93%. Scope for improvement. All right. Answering Q&A. Are these nodes in a block that contains a transaction? No. What nodes? Do you mean RPC nodes? No. As you saw, they're completely outside. By outside, I mean, no, they don't take part in consensus. They don't create your block. They are not doing proof of work. No, their only job is to serve the clients and get some data from the blockchain from time to time. Difference between JSON RPC and C++ RPC. Why can C++ RPC not be used? What is? Oh boy, you're confusing two things, sir. C++ RPC is most probably for one C++ process to talk to another C++ process. It happens on the same machine. Uh, Maybe not. Let's see. Providing both client and server implementation. This is similar to what JSON RPC is. But number one, I mean, if you're using C++ RPC, this is something else. I'm looking at the wrong thing. C++ RPC tutorial. Let's see. I want to learn for RPC communication. I want to learn what's client server side. Can you give me a link of C++ RPC? I mean, the short answer is not every blockchain is written in C++. So, if C++ RPC is, a specific type of RPC that you can do on a C++ server, not every blockchain will be written on in C++. So, that's probably the reason. Also, this is just accepted standard. Ethereum exposed its functionality via JSON RPC, and then every blockchain just followed. And now it's just common pattern for if you want to talk to a blockchain, you use the blockchain is exposing some JSON RPC server. If you looked at it, Alchemy had hundreds of blockchains over here. Each one of them is an RPC server that you talk to. I create a CLI based vault where a person can come and create multiple wallets. Every wallet have multiple accounts. Person can also view balances and also have access to the vault using the password, and they can also see the private key for the wallets. It is working fine, Solana, but I had a problem on Ethereum when I tried to create. It says mnemonic.compute seed is not found. Can you create a Notion doc? Where does mnemonic come from? Where, and also, worst case, look over here. I've already done it. Maybe try to use the libraries that I have used, which I have also copied from Backpack. So, try to look at this code. How am I doing it? And, try to do the same thing maybe. When we send a transaction to a miner and sign it with our private key, miner rechecks it with our public key. But in ETH, our public key is hashed using this algorithm. How does miner able to verify the transaction using the hash public key? That is a great question. Which I don't have the answer for. Probably the verify. That's a good question. I have no idea. That's a good question. I should probably take a screenshot of this and come back to you on this one. How does I can spitball here, but there's no point spitballing. Spitballing means okay, I can guess a little bit, but yeah, I don't know. How does this happen? बाबा हैशिंग में लैम्पोर्ट वही का यूज करके मेमोरी वेस्ट नहीं होता हैशिंग में आई मीन आई गेट द लॉजिक वाई वी यूज देम बट अर्थ पे सो मच क्रिप्टो मेमोरी एनर्जी लॉस नहीं होता so the answer is no. Even if you're storing, 0.001, or if you're storing something like this, they will actually take up equal space. It looks like this will take up less space, but that is not the case. This also has 1, 2, 3, 4, 5, 6, 7 bits you have to worry about, And just because this number is, 0. It looks very small, doesn't mean it takes less space. Still takes equal space to, a number like this. There are still zeros that you have to, store in memory, right? So it might feel like, if you're storing a decimal number, it's, if I'm storing 11.2233, something like this, it is better than me storing, whatever, 1123311300000. That's not the case, and even if it is precision, if the application isn't working correctly, I repeat, if some money is lost, if some 0.0001 soul of mine is lost, I will be more angry. The blockchain isn't safe. That this isn't you can't build a financial system in which you have precision errors, which is why even if this is more memory, you wouldn't care, you will have to build it this way. What if someone randomly use the mnemonic and access the account? What do you mean randomly use the mnemonic? Someone else asked the same question. Okay, Harkirat, list. These are the, words from which you can generate your mnemonic. It is, list of, let's say, 2000 words, 2048 words. Someone else also asked, Kirat, isn't it, can't you guess someone else's seed phrase? The answer is no. The possibilities are too many, right? What is 2048 into 2048 into 2048? Keep multiplying it 12 times. That's a very big number. So, you can't really guess someone else's 2 per 8. It is this, you can't really guess keep guessing or brute force mnemonic phrases. So yeah, do wallets like Phantom store a private key in their database? Preferably not. There was one wallet that did. They did not store it in the database. They logged it in Sentry by mistake. And that of course lost money. Backpack does not. Backpack is open source. You can read through the code base. Your private key never leaves your this thing. In case of Phantom, Phantom is not open source. You can try to inspect requests and check if they store it or not. Most probably the answer is no. MetaMask is also open source. I'm pretty sure they don't. A wallet shouldn't. I think it's very scary for the wallet itself to do it. I don't think any wallet company would want to do it itself because if there is any vulnerability in their backend, they all their users funds go away. So I think a wallet would generally avoid this only and keep it on the client. But you can't really be sure unless you can read through the code base, which you can for MetaMask and Backpack, and actually verify that they don't send any data to the backend. Do we need to? You need to know web dev before making the assignments. If you're in the cohort, we'll learn this in like a month. But that this is why React and JavaScript were a prerequisite to the Web3 cohort. Let's say we are creating our own such kind of website wallet which fetches the data. So how do we know that which RPC to have to send to request the data from the blockchain, as we're doing only on our server? How do we know the main ones? I don't know. I'm asking the right thing. I'm confused. Okay, Krishna. If you are creating your own wallet, web-based wallet that we're trying to create here, that's our first assignment. This is how the UI would look like, right? Let's say there is, this app called My Favorite Wallet. Okay, that's the name of my application. It has two sections. You have wallet 1, wallet 2, wallet 3 on Ethereum. And on Solana, you have wallet 1, wallet 2, wallet 3. Now, if you want to show the user their balance, on this Ethereum side, you will send a request to the Alchemy URL for ETH. What was the Alchemy URL for ETH? If you remember, let me quickly show you. Where was I sending the request? I was sending it to eth/mainnet.g.alchemy.com, right? So this is where I will send the request for the wallets on the left. This is where I will send the request for the wallets on the right. So if you look at, alchemy-eth dot something something, from here I will send request to alchemy-sol dot something something, because all these wallets need to get their balances from the Solana blockchain. All these wallets need to get their balances from the Ethereum blockchain. So you will send the request to the respective blockchain based on what wallet you are trying to query for. For example, if I opened Backpack a while back, when I'm in the Solana wallet, they're sending the request to the Solana RPC server. If I change this to Ethereum, they will send the request to the Ethereum server. When we send our transaction, okay, answer that one. Same issue I also faced with the Weed plugin. Nice. The last zero was also, what was the last zero was, what was that M also? Sorry, what is that statement? Last zero was, what was that M? I did not understand that. Some more assignments for Web3. I mean, if you're able to do everything, then sir, here is a good one for you. If you have created a web-based wallet, what is the next natural step? If you go through this ad hoc video, this is a good assignment if you really want to do it. If you took me a lot of time to figure out this, I haven't completely figured this out. In the ad hoc videos section, where is it? This one right here. You will find a video of me where that I took in the fellowship. And here I talked about wallet adapters. The reason most wallets are extensions is because they need to connect to what are called dApps, decentralized apps. Harkirat, what is a good example of a dApp? Tensor is a good example of a dApp that lets you buy and sell NFTs. Magic Eden is also an NFT marketplace. When you click on the connect wallet button here, it shows you you have Backpack, you have Phantom, you have MetaMask. can you add your own website over here? How will you do that? That is what I talk about in this talk as well. That I did for the Solana like foundation folks. And that's a difficult task. So, this is an assignment for you if you really want to challenge yourself. Okay, you have created a web-based wallet now, but how can you connect your web-based wallet over to dApps, considering it is not an extension? That is what the talk was about. Yeah, wallets were always meant to be extensions, because these extensions can, inject some code in dApps. Doesn't it sound dumb to you, or weird to you? Okay, why are all wallets extensions? The answer was because all of these extensions need to connect to dApps, decentralized applications. And when I saw this application called Tiplink, or this wallet called Tiplink, which is a web-based wallet, I was just intrigued. How do they, have this wallet adapter? How do they work on dApps? Which is what I would urge you to, figure out if you want a more complicated assignment for yourself. If you are able to do it, I can guarantee you will win at least $250 to $500 in the super team hackathon that we're doing. If you're the only one who does it, if you create a web-based wallet that does have wallet adapter integrations with these dApps, very easy money grab or whatever. I don't know, if it's a lot of money for you, like $500 should be something you deserve for making that. Okay. Someone created a simpler code, uh, same thing but simpler code. Let me also put this in the slides so more people can also read through this if need be. All right. Guruji, see this. All right. Someone has also created very nice, not the best UI, but pretty good. Great. Now, what's the next step for you? Balances. After the balances, what is the next step for you? Maybe cache the balances on your own backend server. What is the next step after? Let the user send transactions. What is the next step after? Create a wallet adapter and then submit it on the hackathon. You only have 15 more days left. Hey, can you generate a wallet? We can see the public key, right? How to get the private key? Hey, when we generate a wallet, oh, how to get the private key? So for backpack, go here, open the specific wallet. Let's say, it's this third wallet right here. Go to, uh, click on these three dots, click on show private key, put your password. It will show you the private key over here. Hey, we generate a wallet. We can see public key. Okay, answer that. Do we need smart contracts to send transactions? You don't need smart contracts to send transactions. You send transactions sometimes, on programs that are not smart contracts. If you want to send someone Ethereum, but on Solana, everything is a program. So over there, yes, technically you do need smart contracts to do anything. But you can send transactions without having your own smart contract, if that is your question. Explain Alchemy one more time. All of these companies that I've put here, not just Alchemy, are big businesses. Alchemy was valued at $10 billion in the last bull run. Infura is owned by Consensus, which is the parent company of MetaMask. Helios is also they raised 30 million or something like that, maybe 6 months ago on Solana. So all of these are good businesses. What do? They're actually very close to AWS. They bring up machines that talk to the blockchain and provide them to end users. Their clients are companies like Backpack. Backpack actually uses Helios as their RPC provider. Phantom also most probably has delegated this to one of these companies. The goal of these companies is to create these RPC nodes that can talk to the blockchain, and companies like Backpack, companies like Phantom can rent these RPC servers from them. Just how you rent machines on AWS, you rent these RPC servers from these companies. And why do you do that? Because you want to send them transactions. Hey, can I get the balance of this specific address? Can I submit this transaction, please? I want to send my friend some money. That is the goal of these RPC nodes. Backpack, whenever you open, it is showing you the balance. It is showing you, your NFTs. Whenever you see this loader over here, it is hitting an RPC server, trying to fetch some data that it will eventually, show you, okay, you have, let's say 3 NFTs over here. When you click on activity, it is hitting an RPC server, trying to get back your transactions and then showing you, I currently have no recent activity here. So all of these, as I change tabs, requests are going out to a server. Backpack doesn't own these servers. They just rent it from Helios, from Alchemy, which is exactly what we did today as well. We went to Alchemy, we bought a few servers, and we were able to send some requests to them, very similar to the request that Backpack sends. All right. Now let me open chat so it's easier to manage. Chat is open, guys. Wow, there's a lot of questions. What is the difference between API.devnet and Helios RPC node? Because both of them can get me balance and how to off ramp USDC to INR. You ping me if you want to off ramp USDC to INR. I do it for a lot of people in the cohort. So if you want, I can do it. Specifically, the RPC URL that you have sent me is a devnet RPC URL, which means you can't really. Okay, for testing purposes, every blockchain has a fork running on the side called devnet, which basically means, as the name suggests, this is not main Solana blockchain. This is a side small Solana blockchain that is running, where when you send requests here, it will return you your devnet sol. It will return you your non-real sol. If I go over to my wallet over here, I can change the network to be, if I go to settings, Solana, RPC connections, custom. Uh, used to have devnet and testnet over here, but basically if I replace this with this devnet address, then it will show me my balance on devnet. Now I have $0 on devnet as well, but I can airdrop myself some money on devnet. I can, if I go to Solana airdrop, so faucet, and put this wallet address over here. Then it will send me some airdrop. As you can see, I have $138, but I don't really have $138. I have them on DevNet. I can just play with them. This isn't real money, because this is just, I am connected to a DevNet, a development environment. If this is, see, if this is the main blockchain, what I just, I have $138 in a side blockchain. I can't really sell this for $138 because this is DevNet Sol. This isn't real Solana. This is infinitely available. Anyone can airdrop themselves this. So that is what DevNet is specifically. DevNet is very different from mainnet. What you have, over here where I'm sending a request is, as you can see, mainnet, not DevNet. But there is a API dot mainnet dash beta.solana.com as well, which under the hood, these guys also use QuickNode or other RPCs only. So, this is just a free publicly available RPC URL. You get rate limited really bad over here. So you shouldn't use this. You can use this as well. If I, replace this Solana URL with this, it will still return, whatever, this much SOL I have, or, get transaction count will return me this much transactions have happened. But, you can't really send it to any requests. If you do it, rate limits you very quickly. We send a few requests. Let's see if it does rate limit me. Would have supposed slash would have assumed it rate limits me. But sure, if you don't want an Alchemy URL, get this free one. But I can tell you, this isn't practical to use this free one because very quickly you get rate limited. All right. What is the difference between private key and seed phrase, since both can be used to get into a wallet? So the difference is that the seed phrase can be used to create multiple wallets ka public and private key. I repeat, if I have someone's seed phrase, I can get access to their wallet 1, wallet 2, wallet 3, wallet 4, wallet 5. But if I have just their wallet 3 private key, I repeat, if I just have their One, two, three. Wallet 3 private key. I can just access the wallet 3. I can't access the other wallets. So every wallet has its own public private key pair. All the wallets that I see over here, wallet 1, wallet 2, wallet 3, have their own public private key. If I get their private key for this wallet, I can access the funds for this wallet, no other wallet. If I get their mnemonic, or more specifically, more technically their seed phrase, but which is, just the mnemonic, either one of these, if I get, if I basically get someone's this, if I go to account, settings, your account, show recovery phrase. If I get this, then I have their seed phrase. Now I can get every wallet of theirs. So if you have someone's seed phrase, they're completely screwed. If you have someone's, private key for a specific wallet, this thing right here, then you have been able to hack that wallet, but not the other ones. Do all students attending the class via live? If so, how are they asking questions fast? At least I'm not able to phrase my question. So what people do is they keep their questions handy on a notepad, and then when I open chat, they quickly paste it. Repeat. It would have just been easier if you asked your question here. Prakaran, but um, repeat how to create RPC server and how do I query it? Sure. How do you? Hey Ragini, I have a question. Right? When a blockchain forks, what happens to the transaction data on the branch that gets abandoned? It is reversed. If there was a fork, um, I'm coming to the RPC thing in just 1 second. Let me just answer this one really quickly. What does a fork even mean? It means, half of the miners have agreed on one thing. This is what the blockchain looks like. Other half of the computers have agreed on a different blockchain. Now, if you are sitting here in India and you query this blockchain, you're like, my transaction is accepted. Yay. You tell your friend, you tell the shopkeeper, Dekho, I have paid you 5 Bitcoin, give me the chips. They give you the chips in return. And they're also happy कि हाँ bhai, I received the Bitcoin. But then the fork gets abandoned. This fork gets abandoned. This white, blockchain is what gets accepted by these guys as well. Then what will happen? Basically, this guy will become sad, right? This guy should have waited. This guy, when he saw a fork, should have waited for a few more confirmations for the blockchain to become a little longer before this guy accepted कि हाँ ये लो भाई अपने chips. He shouldn't have given the chips until the blockchain became slightly longer. If he did and his fork gets abandoned, then he loses his chips ka packet. Yeah. Another question: where should we store our private key and seed phrases? Should we store them in a database, or is it better way to? So you don't store them in a database. You do never put them on a machine only. You write them on a piece of paper. You forget about it. Or you use crypto steel. If you really want to know, if you have money, basically, don't do all of this for like $2. You're spending $100 to buy crypto steel for $2 worth of crypto. Don't do that. If you have substantial amount of crypto, you don't ever put it on a machine, be it a database or otherwise. You put it on a piece of paper. If you want to be really secure, you buy something like crypto steel, put it in a locker, put it in the basement of your house, whatever. Store it somewhere deep. Why do we use low-level programs for generating public and private keys when creating a wallet instead of relying on libraries? Why do we need to? You don't need to. No one does that. As you saw, even Backpacker Codebase uses ethers. It doesn't use any of the low-level libraries. Yeah, there's no reason for you to do it. You can do it. If you want more flexibility, let's say you want some more functions that this top level API doesn't provide you. In that case, you might want to do it, but yeah, generally not needed. Even wallets, some of the biggest wallets, simply use the ethers library or at solana/web3.js library. Don't really use the underlying lower level library, like whatever the ones were that we've discussed. Is Ethereum public key 20 bytes including OX without 0x? It's 20 bytes without 0x. Difference between these two, why are we using NACL if Solana web3.js already has a key pair.from seed? NACL.sign.keypair.from seed, web3.js equal to keypair.from seed. No reason. If they do the same thing, let's try it out. Where can I quickly try it out? There's no, if they give you the same output, Then there is, oh well, there is one small difference. Yeah, the reason you might want to do point two, the reason you might want to generate a key pair is because this key pair class provides you a bunch of Solana specific things, right? Not really, if I'm being honest. It gives you access to the public key, the secret. It gives you a very easy conversion for the public key to base 58. That's it. So if you need access to this high level key pair class that Solana has created, then you use the second option. If you don't need that, you just need the private key in, let's say, the form of a bunch of bytes, then you use the first one. Usually, whenever you're using the NACL library, you use it to finally spit out a key pair only. If you ever want to you create a Solana program, you want to have access to this key pair object, which is why you either directly want to do what you've done in the second point over here, or even if you're doing the first point, you eventually convert this secret over to a key pair only. So basically, I would do point two. There's no difference though, as long as they're outputting the same private key, which they should, looking at the function signatures. There's no difference, but usually you do the second one. Um, what advantage just does JSON RPC provide over HTTP? Isn't it just HTTP post call over a predefined body? But the answer is yes. RPC generally, even I don't get what the benefit is. Usually the people say the benefit is you're almost calling a function. If you ever use TRPC, that is their pitch. It feels like you're just calling a function, even though under the hood it's an HTTP call. So yes, in terms of the network bandwidth you're using, in terms of the performance benefits, it is still an HTTP call. I never understood the appeal of RPC for the same reason. But the appeal is, or the pitch is, it's like you're calling a function on the front end, but under the hood it is sending an HTTP request. That is, if you've heard of server actions and Next.js, they're also similar. Okay, hey, you're able to call a function which under the hood is sending an HTTP request. Is that too big an appeal? Maybe. I don't know. But yeah, never found the appeal of RPCs. The creating an HTTP server is, yeah, good enough, same performance as you said. And, uh, I'm sure if you Google what is the benefit of RPC over HTTP, it will give you 10 reasons. But practically never understood any, good reason for it. Unless you're using something like gRPC, because you're, compressing the data, you have some data format, you have a proto file in which you're putting some, describing your schema very well, then sure, there is some benefit there. But for JSON RPC, yes, no real benefit that I can think of. Does add slash web3.js function get balance also call the RPC server under the hood? That is correct. It does. How else will it do it? Let's look at it. Solana slash web3.js GitHub. Get balance function. If you look at packages slash RPC API slash source slash get balance, the name itself says RPC API. If you look at the get balance function, this is the signature. Let's see. Get balance.ts extends RPC methods. This is just the, see, this is the function signature. It does not have, where is the actual implementation? Let's see. Balance subscribe rpc.get balance. Sorry, I'm getting a little distracted here, which I shouldn't. But if you look at it here, yes, it will, unless I'm wrong here, 99%, see, be sending a request under the hood to an RPC server. Let me try for like another minute and then I'll stop if I'm not able to find it. This just exports a type, does not export any implementation. What was the thing called? Let's see. OD. Let's search for this. Yeah, can someone find it? I'm sure it's like, unless it uses like another library like this. I don't know. Yeah, I'm sure when I open chat the next time, so I'm sure someone will point us to the right file. But yes, I'm pretty sure it does the same RPC call under the hood. Is it better to use RPC servers to fetch from the blockchain or use something like, so it's the same thing, right? Most probably we'll see very soon. Someone will post the actual implementation of these functions. But yes, these functions should, I mean, you can confirm this by doing something like this also. Replit. Let me spend another minute here to just confirm this. The thing that you said was, where do we pass the cluster when we are creating? So great question. I will share that very soon. That's when you create the connection object. Let me just write some code for you here. Const web3 equal to require at Solana / web3.js, and const connection equal to new. I think inside here is where you pass the RPC URL, which in our case is, let's say something like this. It would have been nice if I used TypeScript. Okay, Akash, can you mute, please? Thank you. Oh, I don't think he did. Where's our guy? There we go. All right. Yeah, this logged. So what was it? Dot get balance, and then the address, which let's say is this address right here. So this is what you were talking about, right? The get balance function, does it actually send an HTTP call? How can we confirm? We actually can't confirm it like this. Yeah, we can't confirm it like this, unfortunately. But if I run the same code basically in the browser, let me quickly do that. Wallet. Something like this. Get balance. I hope you get a little bit of what I'm doing. I'm just sending that the request that you asked about. Okay, Harkirat, does this get balance request send a request? Does this get balance function call send a request to the HTTP server under the hood? We can confirm that by making that get balance call and then opening this in a browser and then seeing, is there a RPC request that's going out? There isn't. Let's see. Oh, it only happens once. Let's refresh. And if you look here, is there a request that goes out to? There's no request that goes out. Let's do alert. Hi, refresh. I don't see an alert. Why? ETH wallet is never. Oh, it's my bad. Create seed phrase. Okay, there you go. This happened, but no request went out here. Was anything logged? Oh, there you go. It needs to be key. Refresh network. Oh, still an error. That's fine. As you can see, the same RPC call, went out. Solana mainnet. This is the RPC URL. If you look at the data that I'm sending in the payload, it is, method, the same JSON RPC URL. So to answer your question, a very long way to answer your question, this function call does indeed send out the same HTTP request. Doesn't matter if you're doing this or if you're doing an Axios.post. It's the same thing. Doesn't matter. It's the same performance either way. All right. Moving on. Okay, if my mnemonic is fox over in home, but I wrote cow over in home, this will lead to another wallet opening and the population also increasing. It will lead to another wallet opening. What do you mean population increasing? I don't know what pollution. No, I don't know what population increasing means, but yes, it will lead to another wallet. If you change any word in your seed phrase, it will lead to new set of wallets. Question related to Sala Hackathon. Can you discuss this decentralized freelancing project in a little bit more detail? How you want the project to be? It basically needs to look something like this. So firstly, the UI needs to be, as polished as this one right here. And when you go and look at a freelancer's profile, let me, let's say select programming and tech. And then I makes me log in. But when I reach the profile page of the user, let's say, website development, this person like here, when I should see a page like this, I should see their, offerings that they have. When I click on continue and pay, it should let me pay via Solana. This money should reach an escrow. Whenever their task is done, maybe I should have a place where I can message with them. Whenever the task is done, the escrow should release. So it's basically building something like Upwork, but using Solana for payments. It's not too much of Solana logic, more of simple building a Fiverr like platform or Upwork like platform. If collision is almost impossible in case of hashing, um, what would happen if it occurs? What would happen if it occurs? In case of blockchains, in case of, when are we using hashing? We are using hashing if, let's say, proof of work. If there are two things that collide, does it really matter? Doesn't really matter. You were able to give a proof of work. In the future, another person gave proof of work, collision happened. Probability is very low. Of course, there will be bad things that can happen also. I'm just not being able, I'm just able to think of one really bad thing that will happen, but there will be really bad things that can also happen if, a collision happens. Do we have any provision for handling the mess it would create? So in case of proof of work, it will not create any mess. The reason it might create a mess is if, you know, two different Ethereum wallets, or two different Ethereum public private keys or key pairs converge to the same, public key. I repeat, this will create havoc or a problem. If this happens, what was the way to create an Ethereum wallet? It was this, right? This complicated way to create the final Ethereum wallet. If there is a collision over here, different public keys lead to the same 32-byte string, which leads to the same public key. That's an issue, right? Clearly, this will lead to two different people who have different key pairs having the same public key. If that happens, and of course you're screwed. And what can you do? Two people are only. I mean, this will never happen. Like realistically, of course, you can think of very weird edge cases, but the probability is so low, it will not happen. I said, bhai, what if two people get the same seed phrase? BIP30 is just 2,000 words that you choose. The BIP32 list is just a list of 2,000 words. What if two people get the same mnemonic randomly? The probability is very low. It can still happen, but has never happened till date. It has never happened, some person had one mnemonic phrase which had millions of dollars in it, and another person randomly generated the same mnemonic phrase. So you can predict these things in mind, but it never practically happens. So there's no point even discussing it because it will not happen. And if it does happen, we'll see how it gets fixed, or there are ways to fix it, right? I mean, if literally the blockchain might kick in, then in that case, if this is happening too often, then the algorithm might change. Rather than having 12 words, you need to now have 24 words, 48 words to make it more and more difficult for collisions to happen. माइनिंग से एनर्जी लॉस होता है, कौन पहले करता है कौन बाद में, जिसने बाद में किया एनर्जी लॉस हुआ? माइनिंग से जो एनर्जी लॉस होता है होगा कि कौन पहले करता है कौन बाद में, तो जिसने बाद में किया एनर्जी लॉस हुआ. यस, इफ यू have a Bitcoin rig that is not able to mine for years, yes, you will have a lot of energy loss and electricity loss. That's, unfortunate and the bet that you take. 44 is the 44th level of the derivation tree. Could you elaborate a little more on that? And what does that mean again? Bhaiya, how to inspect the requests of the extension? Oh, you can just click on it. So if this is the extension, let's say backpack, inspect, you have the network tab over here. Now you can expect all the requests that go out. In case of wallets, they usually proxy requests to RPCs. So you won't be able to see any RPC requests. So what happens in case of wallets, just to make them fast, what happens is, if this is the backpack wallet, it sends a request to, API dot, one second. backpack.com, which, under the hood, let's say, hits an RPC server and, caches a bunch of values here, things like these. So even if you inspect a request here, you might not see a request directly to an RPC. You might see a request here, which under the hood sends a request to an RPC, and, caches a bunch of things here. Can a transaction only be fund? Can't we do transaction of messages? What does that mean? Can a transaction only of fund? Do you mean, is a transaction only to transfer money? The answer is no, especially in case of Ethereum. We'll see very soon. You can, people have put various smart use cases on the blockchain, and, um, you can just call a function on that smart contract. You don't have to necessarily transact anytime you're interacting with the blockchain. Software solution to identify the end receiver of a cryptocurrency transaction. This is the only problem in SIH24. If we can identify who the end receiver of a cryptocurrency transaction, does that mean we are finding the weakness in the blockchain? Since blockchain is supposed to protect user privacy, won't this go against the idea? What is SIH24 to begin with? Smart India Hackathon 24. Software solution to identify the end receiver of a crypto. This is one of the problem statements in SIH24. Oh, acha, okay, I get it. देखो भाई, you cannot find the source of a transaction, but people are dumb. What people do is, okay, this is, let's say, my anonymous wallet one. This is my anonymous wallet one. I in the past sent $10 to another wallet of mine, which is also anonymous. Let's say wallet two. But then I sent it to another wallet three, which is also anonymous. But from this wallet three, I sent some money over to Binance. Let's say now Binance has my KYC information, right? So you can actually link this wallet over to who this person is. So it isn't a weakness in blockchains. It's just a weakness in people. Okay, people are dumb enough to keep transacting. It's very easy to see someone's circle like this. There are companies like Chain Analysis, who's as the name suggests, they let you analyze the blockchain, and you give them an address, they'll give you the whole Jala of who has this person interacted with. Eventually, it concedes on a Binance or a Coinbase. So you can always find someone that they have sent money to, who might have sent money to someone whose KYC you can find. From there, you can try to backtrack. अच्छा भाई, तुम्हें ये transaction किसने भेजी थी? Who sent you this transaction? Then you can ask this guy, who sent you this transaction? And eventually reach the source. It's not a weakness in blockchains. It's just people can send transactions in a way they can be found out who this person is. Harkirat, wallet like Phantom, can we create multiple accounts? Is each account a separate wallet? And if yes, does account have separate seed phrase? Then why do you say one seed phrase can guarantee multiple public keys? Because each wallet will have only one private and public key, right? Harkirat, okay. There is a single seed phrase. I repeat, if you open Phantom or if you open Backpack, the seed phrase is singular. Uh, the mnemonic is singular. Every wallet has its own public and private key. If you remember the diagram that I showed a while back, which is this one right here. There is a single seed phrase. When I open Phantom or Backpack over here, and it doesn't matter how many accounts I create, all of these accounts are derived from the single seed phrase. This single seed phrase is derived from a single mnemonic. And from the seed phrase, I can create multiple wallets. Each wallet has its own public and private key. I repeat, each wallet has its own public and private key. But the single seed can be used to derive all of these individually. And of course, the public and private key that you have in these wallets, if you leak this private key, then your this wallet is screwed. If you leak this private key, this wallet is screwed. But there are different private keys. That doesn't mean there cannot be a single seed phrase. There is a single seed phrase which lets you create multiple wallets. Each wallet has its own public and private key. RPC is like an API, then yes, it is like an API server. Generate a mnemonic. How many wallets do you want? 8. Nice. 9. Nice. Pretty good. Um, if the attacker got the access of HD wallet seed, will he get access to all the wallets based on seed? That is correct. Are there any applications which can store recovery phrase securely? No, only a piece of paper. Every application might have, some vulnerability or other. You should always store it on a piece of paper. If public key is meant to be seen by everyone, why developers go through complex work to create public key? They don't go through complex work to public. They only try to, by complex work, you probably mean hashing and then, converting it into 20 bytes. That's not done for security really. That's done because number one, the original string is very big. It's 65 bits, which will be a very long string. So, they pad it down to 32 bytes. Why did they go from 32 bytes to 20? I have no idea. And I don't think there's a security reason for it. I think it might just be convenience or something like that. All right, I answered that one. More review. Can you create a transaction now and send it to the network later with some trigger is met? Yeah, that's what's called cranks. So there are a few differences. On Ethereum, this happens from time to time. Ethereum has this concept of a mempool. We'll discuss this eventually, but you might submit a transaction once and it eventually reaches the blockchain after 2 hours. Solana, that doesn't happen, but Solana has something else called cranks, which few people also built in a few blockchains that pretty much do what you're talking about, which is on a certain timestamp, a certain this thing should happen. Event should get triggered, or transaction should happen. Can you sign a transaction now? We answered that. Difference between these two, answered that. Uh, Answered that one. Okay. Repeat how to create an RPC server and send a request to it. Go to alchemy.com. Sign up over here or sign in over here, depending on if you have an account here. Create a new app. Click on create a new app. Give your app a name. From description, select a use case. Click on submit. I cannot do it because I have reached my limit. Then it will create a apps, one app for you. I already have 5, so I can't create a new one. It will create an app for you. Click on this app, go to networks. It will show you your RPC URLs for all the blockchains. If you want to query Ethereum, go here. If you want to query Solana, this is your URL for that. If you want to query, BNB, Polygon, Mantle, it gives you RPCs for everyone. And each one of these blockchains will have, their own methods that you can call on them. For example, on Ethereum, you can call the ETH underscore get balance method. What are the arguments you need to pass in it? कि किस account का balance चाहिए? Which accounts balance do you need? Which in this case, let's say is this public key that I have. It returns me, भाई इसके पास तो इतना Ethereum है. This has this much Ethereum. This is in hexadecimal. You can convert it to decimals, or a number. That is how you query the blockchain. Number one, you get an RPC URL from Alchemy, Helios, whatever. Once you have it, you can send it a JSON RPC request with the method that you want to call, which in case of Ethereum is this ETH underscore get balance method, and the parameters that you want to call it, which in this case is, the current address, let's say, the address of your friend who you want to query. Cool. Answered that. Also, are private keys only used for recovery and signing transactions? Private keys are used for recovery and signing transactions only. Yeah. I can't think of a third reason why you would use private keys. Can we use these RPCs on DevNet? If so, how? If they're only for mainnet, I think they're for DevNets. Configure. Let's see. I remember an app. Let me delete an app and show you. There is a way to do it. What you're asking. Settings. At least for I remember you. Let me just delete one of these and create a fresh one. Settings. Apps. Create new app. Test. Where's the submit button? Next. Here, let's see. Solana. I select Solana for next. Hmm. Oh, there you go. Select DevNet over here. Mainnet, DevNet. If you select DevNet, it'll give you a DevNet URL. Um, can you please share so the slides would be soon posted on projects.100xdems.com. So you'll find them here at the end. Making this a little bit cleaner, by the way. So yeah, just wait for like an hour or two. You'll find the slides here. If you want the link to them, they're also right here. Pasting the link in chat. All right, let's do one more, and then we'll call it, guys. Any more questions? All right, start from the top. Too many of them. Notion doc, less janky. Um, looking for constructive criticism. It has integrated Google Calendar. Yeah. So I think I mentioned this before. The good thing about this is the content. Not so good things are, constructive feedback is you don't need this is too fancy for, basically you don't need some design sense. You can always, depends on whether or not you want to be a designer. But the reason Keshav's project impressed me was because it was very polished. Here it's like too much is happening. You don't need any of the back end, whatever stars are going out. And yeah, it's pretty plain design, right? A calendar view would have been nicer. If there's a calendar, if this calendar has this class happened on XYZ date, when I click on that, models pops up that shows me the slides. That would have been much cleaner than what we see over here. What is this button? Oh, there is a calendar view. Okay, looks very ugly though. You get the idea. You should design it from scratch rather than whatever this is. So yeah, like the UX is so bad. I didn't know what this calendar does. Would be just nice if there's a very clean calendar over here, very similar to Notion calendars, and like fairly clean. And you click on the specific event, it shows up. Yeah, these are the set of events that happen. But I do appreciate the content. The content is like solid. Um, how you can add your own calendar here. I don't know if people will do that. I think it's just easy for us to create a global calendar. Okay, Notion doc. Explain Postman part. Where is shown balance on my account after sending the request? So Postman is something we'll be covering in the web dev cohort soon, not soon, like in 2 weeks. Postman is a application very similar to GTA. GTA is an application. Google Chrome is an application. Postman is an application. What does Postman do? It lets you send requests to these servers, RPC URLs. We remember the architecture that we had for front end versus back end. It said, okay, there are users on the left, there are backend servers on the right. You send requests to these backend servers. So what Postman lets you do is send these requests to these backend servers. It sends the request, gets back a response. This is the URL where it sends the request. This is the body which it sends the request in. Okay, I want to get the balance for this specific address. Let's say I send the request, I get back the response. That is what Postman lets you do. If you look at my history, I use it for a bunch of things. If I go really bad down in the history, you will see the websites that I sort of tinker with or try to hack from time to time if I keep going down. So the purpose of this specific sort of application is to be able to send requests to various servers. Sarkis, why don't you send requests directly from browser? You can, but this is just easier, right? Clicking a button and getting a response like this. That is why you use Postman. The tip link package code right here, npm, we use the code to achieve it, right? Not above zero is the last zero. What's that for? I think that's for the sub account. You know, one is the account. I think zero is a sub account. For example, I could be wrong actually. Add account. No, this creates a new seed phrase. Never mind. It's not what I thought. In the above code zero. Let's see. I mean, there's a graph that you can look at, or this. What was the proposal? BIP 39, right? Which introduced these derivation paths. वहाँ पे they've clearly written, what each one of these represents. Sorry, I have created a Telegram bot. Send whale alert if exceeds 1 lakh USDC. Um, Command for getting any token info. Nice. New listings, top tokens. Add like swap functionality. Add functionality for users to create their own wallets. That's what BonkBot does, right? It's in the end, creating wallets for people. It becomes super useful when ETH whales want to move to Sol. So maybe try to add something like that. Anything else I can do? Yeah, basically. Oh, for the hackathon, this is pretty good. Yeah, just add the one thing that's left, which is letting user create their own wallets and swap things like these. Oh, let's see. I like it. Who is reviewing these? I love the design. Um, if it gets merged, if it gets merged, that is deserves $100 bounty. Hopefully it does. Looks pretty clean. I mean, other people can just build on top of it, but I like it. Have you added everything? How can admins add these? Can only admins add these? Um, I don't know. We'll see. So don't. Yeah. Unfortunately, I don't have the time to review this, but hopefully someone will soon. Um, we should build a sex text before Web3 code ends. Who knows, might become something. So the thing about a sex is I talked to a few people. It's actually not too difficult to get a license, but Binance came back. I don't think anyone think about Indians. I don't know. Flipkart was able to compete with Amazon. But I don't know. I think after Binance is like a little hard to compete as a sex. But we'll see. Or getting a license is not too difficult. It also is a full-time commitment, creating an exchange because you're holding people's funds. You can't do it passively. So we'll think about it. Lex to bhai, just create a wrapper on top of Radium. You're good to go. You don't really need to create. I mean, just find distribution if you want to create a DEX. You're not following any laws in that case. So you can just create a wrapper if you want to deploy your own contracts. Either way, there's a challenge that is bringing liquidity and market makers than anything else. The tech of building a DEX is fairly simple. What is the next week's topic? Next week, if you look at the syllabus, we'll try to finish up everything in this first section right here. Hopefully, finishes up the project that I showed as well. But the goal for Web3 for next week is, you understand all of these things that are left. We sort of understand it, but we'll dive a little bit deeper into the Ethereum architecture and the Solana architecture. Hope is we are able to complete all of this by next week. So, we can get into EVM from the week afterwards. When anonymizing crypto, people use mixers, which break on big amounts, which break big amounts into smaller chunks and to many transactions till it becomes too difficult to trace. Sort of. So my question is that each transaction costs some transaction amount. So does Mixer, who do many transactions, reduce the amount drastically? It doesn't reduce the amount drastically. I don't know if mixers let you do what you're saying. I think they do something different. You put in 100 ETH, you pull out 100 ETH, it just gets mixed with other people's 100 ETH. So I don't think you can put in 100 ETH and pull out 1 ETH. I don't think that happens. Could be wrong, but if it does, also then it's not too much fees. Can we copy Tiplink UI for the hackathon? Yeah, like Tiplink ka UI as it is copy. Since Swiss bank have very high anonymity, in the ideal, someone should withdraw only to Switzerland. I have no idea. It's like out of scope for me, understanding how Swiss laws work and why people put their money there. No idea. Is it common to use gRPC in Web3 Rust packets or standard HTTP posts? Usually, I haven't seen gRPC being used in any blockchain code. I've also not seen standard HTTP posts, if I'm being honest, like very weird P2P libraries that are written that, connect. libp2p is one, for example, that, connects machines all over the world. Do wallets store a public key in their database? And when you create a new wallet, we need the index of that last wallet while creating the derivation path. No, it's all stored here. At least for Backpack, it is all stored locally over here. You never send any of this, the index of the, whatever wallet or the private key ever to a server. I would assume that's the case for Phantom. That's the case for MetaMask. I think it will be a pretty deadly move to do that, to store any of these in their database. Bounty management platform. Looking forward to that in the hackathon. Let me see a little bit of it. Attempt one less janky. Okay, answered that. Sex text, answered that. Please know the live link registering for hackathon. There's been project live link should be there. Help me know about the live link regarding the hackathon. If there is a project live link, should there be why there is message below apply for now button? Don't worry about it. Like we'll figure it out, right? It's fine. There are 15 more days. Focus on the project. Submission is something that can happen. When anonymizing crypto, people use mixers. I answered that one. Can I learn React in 2 days? If you know JavaScript, then probably. Hey Ragini, I think misunderstanding with the earlier question. When creating a wallet, what's the best way to store the user's private key and seed phrases? Should they be kept in a database, or is there some more secure method to persist them? When creating a wallet, you mean something like this. You store them in the user's browser itself. You never take this and put it in your own database. If you're creating a wallet like this, when creating a wallet like Phantom or Backpack, the user's private key remains in their browser. If their browser ever dies, poof, it is gone. You never pack it up in your own database. If that was your question. If not, then let me know and I will refresh this page and just change your contents over here if that was not the question. Um, Start from the bottom here. So I think Keshav created. I think the thing Keshav created is that he's creating a different mnemonic for each one. I think so. When I was creating, I realized that. I know it's difficult to store all of them, but it's safer. I think. Then why do you need mnemonics or HD wallets in that case? You don't need hierarchical deterministic wallets. It is safer, but it's also like 10 different keys you have to manage then, right? So it's pros and cons. Do you want a single seed phrase? It's convenient, but if you lose it, all your wallets are gone. Or do you want multiple seed phrases, in which case, yes, it is safer. Um, pick and choose. Do you want convenience? Do you want security? I am so much annoyed with the errors thrown and the by me at the PowerShell in W. You should try using Git Bash. That usually works. Don't worry about command prompts. Or sorry, WSL just yet. There's this thing you can download. When I had my Windows machine, I downloaded it. A lot of people in Code 2 also tried it. It's called Git Bash. Download Git Bash, and it'll probably give you access to Bash, which is what you need. All right. Okay, so just a few these things, questions, or a few like reviews. Um, I'll create a next project with this thing and this thing. When building the project for hosting, it is throwing an error. Failed to load bindings. Pure JS will be used. Due to this, I'm not able to host the project at all. Can you, when you run npm run build locally, does it work? Have you converted all of these to client components? Are they server components? Either way, shouldn't matter. I say, if npm run build works locally, it should work on Vercel. If it is not working on Vercel, then there might be other errors. Try commenting out at solana/webp.js and at solana/SPL token and see does it deploy then. And if it does, then then it'll be a hard debug. But I would assume the answer, the problem isn't in these libraries, but somewhere in your code, npm run build is facing. So try an npm run. That's how I just give you steps of how I would debug the same thing locally, on myself if I was stuck. It would be either first, number one, checking if npm run build works for me locally or not. If it does work for me locally, then commenting out these libraries and seeing which comment actually makes the build succeed, and then debugging from there. When we generate a new wallet, isn't the private key being stored in the wallet provider like Phantom or Backpack? Where are these guys storing a private keys? When I build one wallet, where should I store these private keys and seed in the database? So no database, as I said. These should never be stored remotely. They get stored in the user's browser. This is where they should stay. Never take the private key of a user. Store it in your database. Keep it in the browser. If the user ever uninstalls this or deletes their application, or their laptop dies, their private key dies with them. You never store them on your own database, right? Cool. Let's answer some little more questions and then we'll go from there. So the id.json file from the Solana contract is a JSON RPC file that calls the function from Solana. Is that correct? IDL gives you, as the name suggests, what is the full form of IDL? IDL full form, interface description language. It will not give you the exact JSON RPC functions that you can call. If you have an IDL.json file, you cannot put that function name, whatever your application is, let's say, send underscore money over here and expect it to work. It gives you a structure of your project, that is correct. But when you're sending the request, I could be wrong, but I'm pretty sure this is right. Okay, when you're sending the request, you still have to, hash the final function name into some very long string, which is what I confused you too much, didn't I? What I was saying was basically, I don't think, given the ideal, whatever the function name is there, you can just put it over here and be good to go. I think whenever you want to call a function on, let's say, a smart contract or a program, the function name gets hashed into some, unreadable string, which is what goes to the server. It's a bunch of bytes that go to a server, rather than, the function name directly going as a method over here. That does not happen, if that was your question over here. Is JSON RPC file a function? Is that correct? So yeah, I don't think that is correct. I think that is incorrect. Is there an application that cumulatively manages its various wallets? I mean, these wallets only. Like Backpack is one such wallet. How much more accumulation do you need? It has account one. If you want, you can add another account. Every account has its own seed phrase or mnemonic. Inside every wallet, you have every blockchain that's possible. Solana, Ethereum, Bitcoin. For every blockchain, you can have multiple wallets. How much more wallet management do you need? Do Dropbox accept